So now that we spent some time reviewing sine and cosine, radians, and how to find values, we're going to do two more things related to trig. The first thing we're going to do is talk about our other trig functions. So once we have sine and cosine, we define these four other trig functions: tangent, cotangent, secant, and cosecant, in that order. So tangent and cotangent are really similar. Tangent is sine over cosine. This one you kind of just have to remember that tangent is going to be the sine over cosine, and cotangent is just the flip of that. So if I flip cosine over sine, that switches tangent to cotangent. The second two, the thing that helps me remember which one goes with which is that the cos do not go together. And what do I mean by that? Well, on the bottom here, you have cosine, and that gets paired with secant that does not have a co in front of it. Here you have cosecant, which is paired with sine that does not have a co with it. So you can see the cosine, and cosecant do not go together. So that helps me remember that secant is 1 over cosine, cosecant is 1 over sine. All right, so if you know tangent is sine over cosine, and the cos don't go together, that can help you remember the definitions of these four new trig functions. And the thing we're going to have to do the most with trig functions, these other four trig functions, is kind of simplifying expressions. Sine and cosine are really nice. We can find the values using the unit circle and all that. But a lot of times we're going to have to simplify these expressions. So if we want to simplify expressions, most of the time we just use those definitions to rewrite things in terms of sine and cosine. So tangent squared is going to be sine squared over cosine squared. Sine is already sine, so we don't have to change it. And then cosecant is 1 over cosine is 1 over, cosecant is 1 over sine. Because cosecant starts with the CO, it's 1 over sine. And you can see here, sine times cosecant, this sine on the top and that sine on the bottom are going to cancel. And we get sine squared x over cosine squared x plus 1. And in some applications, you could probably stop here. You have it in terms of sine and cosine, which we're good with working with, and a 1, that's fine. Other situations, you might want to combine all this into one single term. So you can get a common denominator, and you could say this is the common denominator on the right-hand side is going to turn it into cosine squared over itself. And now I can combine these two fractions. And again, in some situations, this would probably be a fine place to stop. But we have this really nice thing called the Pythagorean Identity. That whenever you take sine squared and add cosine squared, that actually simplifies down to 1. That's a helpful extra thing to memorize because it simplifies a lot of expressions. Sine squared plus cosine squared equals 1. All right, so this top here turns into that 1. And now it gets real simple because 1 over cosine is secant. So our final answer is just secant squared. All right, so we took this more complicated expression and just turned it into secant squared. And for antiderivatives and stuff, it's going to be a lot simpler to work with a single trig function instead of a bunch of trig functions all at once. All right, something similar for secant of x minus cosine. Again, secant is going to be 1 over cosine minus cosine. And again, for some applications, this might be good enough. Other applications, you might want to combine these. So if I combine these, I'm going to get 1 over cosine minus cosine squared over cosine. I've been multiplying the top and bottom of this by cosine over cosine. And that's going to be 1 minus cosine squared over cosine. And this goes back to this identity we have here. Sine squared plus cosine squared equals 1. If I were to subtract this cosine squared behind the 1, 1 minus cosine squared is going to be sine squared. So that combines two terms into 1. So this might be your final answer. And that's, again, some cases this is going to be where you want to stop. Other times maybe you want to just get it as no fraction. So I could rewrite this as sine over cosine times sine. As you're just splitting up that sine squared into two different pieces. And sine over cosine is tangent, and sine is just sine. All right, so secant minus cosine is tangent times sine. And it really all depends on which situation you're in, depending on where you want to stop. All right, sometimes just getting to the point where there's only original trig function, sine and cosine, maybe that's where you want to stop. Maybe just having sine and cosine is where you want to stop. Maybe having no fractions is where you want to stop. It really depends on the situation. But if you can get between all these steps, it's going to help you kind of figure out along the way what you're doing easier. So if you're taking derivatives, well, you could probably just take the derivative at the beginning. This is probably the simplest one. Same thing with taking an antiderivative. Maybe this one's easier. Maybe this one's easier depending on the situation. It's helpful to be able to go between all these different relationships with the trig functions. The other thing that uses all 6 of these trig functions is Sohcahtoa. It relates the angles of a right triangle to the sides. Of course, sine is the opposite side divided by hypotenuse. Cosine is adjacent divided by hypotenuse. Tangent's opposite divided by adjacent. That only gives you 3 of your trig functions. If you want to get the other one, for instance, what is the cosecant of theta? Well, here you said, remember, cosecant is 1 over sine. So it's going to be the opposite of the sine one. So sine is opposite over hypotenuse. Cosecant is going to be hypotenuse over opposite. So knowing Sohcahtoa, even though there's only 3 trig functions in that acronym, it gives you the other 3 just by flipping the fractions. And this allows you to just answer questions about right triangles or make equations with right triangles, which we do a lot in class. So over this, we have this right triangle. One of the angles is 30, so let's just call this one 30. And the hypotenuse, which is always the one across from the right angle, is 5. What are these 2 values going to be? Let's call them A and B. Well, here I can take, say, the sine of this 30-degree angle. And the sine is so opposite over hypotenuse. So opposite from 30, you go across the right angle, is A. The hypotenuse is 5. To solve for A, I'm going to multiply both sides by 5. And in some cases, you have to put this in a calculator, but sine of 30 is one of those nice ones from the chart. Sine of 30 is 1/2. So you get 5 over 2. So A is 5 over 2. Finding B is going to be similar, but instead of doing sine, I'm going to do cosine. The adjacent side is the one that's touching the angle, so that's B. Multiply both sides by 5. And again, sometimes you have to put this in a calculator if it was like the 32-degree angle. It's not one of those nice ones, but 30 is one of those nice ones on our chart. The cosine of 30 is the square root of 3 over 2. And we get 5 square root of 3 over 2 as our final answer. So those are our 2 other sides that we didn't know at the start using Sohcahtoa. Students generally do pretty well with Sohcahtoa. The only thing is sometimes you kind of have to guess and check the angle that you do. So maybe if when I was trying to find B, maybe I tried tangent, but tangent is A over B. So maybe you don't know the tangent values as well. So you can always do a little bit of guess and check with what is the appropriate trig function for what you're trying to do.